Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azim bin Ahmad. My matric number is AA191548. So now I would like to talk about the lab activity 1. How it functions. Okay, so for the circuit 1, despite not manually pushed, the piston has already been extended. You can see the direction flow path. The compressed air has already been moved into the airway of the valve. This controls the movement of the cylinder. When we manually push the switch, the valve will slide to the right. This will allow the air supply to shut off from here. The cylinder will be retracted by the spring. If the switch is released, the valve will retreat back to its original position and cause the air to move back to piston. Okay, so next, circuit number 2. Rest position, the air supply is shut off. When the switch is manually pushed, the value will slide to the right. Looking back at the direction of flow path, the compressed air will flow into the cylinder. This extended the piston. After the switch is released, the valve will slide back to its position. The spring will retreat and then retract the cylinder. Okay, so for circuit 3, when the switch is not manually pushed, the piston is retracted by the force of the air. The force of air is supplied by the compressed air here. So look at the flow of the path. Air is moved into the cylinder. Now, pushing the switch manually, the valve will move to the right. The compressed air will move to the cylinder, causing the piston to extend. The previous air behind the piston will be released through here. Through this flow path to return the piston into its position. Press the switch again. That is how it retreats back to its original position.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Usamah bin Nazar and my matric number AA191939. So today I would like to present about observation for lab activity 1. Observation number 1. Tabulate the list of components used in figure 1. Okay, for the circuit number 1, for the first component is compressed air supply, single acting cylinder, and 3-end wave valve. And for the circuit number 2, we can see first component compressed air supply, and next component single acting cylinder and 3-end wave valve. For the circuit number 3, we have compressed air supply, double acting cylinder and 5-end wave valve. Observation number 2. Discuss the difference between the two actuators below. The difference between the two actuators is the left actuator is push button and the right actuator is manually push button. The push button is push and hold while the manually push button just push to start and to close. The push button just release and the manually push button push again. for the question number 1, lab activity 1. Describe the function of spring for components A1, A2, A3, B1 and B2. The spring at 3 two-way valves or 5 two-way valves is used to return mechanical operation to the base position. A pneumatic cylinder is a linear actuator that works with compressed air. The cylinder's main parts are the pistons, the piston's rod, the cylinder tube, gasket, and seals. Single-acting cylinders also have a spring inside the cylinder. A single-acting cylinder works with compressed air to actuate the piston in one direction and spring force to return to the base position. So basically, the function of the spring at A1, A2, A3, B1 and B2 is to return back to the base position. Question number 2. Explain why B3 does not need a spring. A double-acting pneumatic cylinder is one where the thrust or output force is developed in both extending and retracting direction. Double-acting cylinders have a port at each end and move the piston forward and back by alternating the port that receive the high pressure air necessary when a load must be moved in both directions, such as opening and closing a gate. Air pressure is applied alternately to the opposite ends of the piston. Application of air pressure produces a thrust in the positive push strokes and thrust in the negative pull strokes.
Okay, so for lab activity 2, let's go to the phase 2. Okay, we have already run the simulation for the circuit. Now, we push the switch, and then we push again for the piston to return to its original position. So from here, we can actually see that we have one-way flow control valve implemented into the circuit. So this control valve actually plays a big role in order for the compressed air flow into the space inside the cylinder. When we push, the manometer will take reading of the pressure that has successfully inserted inside the cylinder. And then when we repush the button here, it will reset back to the 0 as it takes the reading here. Then we have already set it to 10%. When the original one is 100%, so this one actually decreases the pressure from its original setting.
Okay, for observation number 1 for lab activity 2, discuss the effect of setting B1 and B2 equal to 10% to the operation of the pneumatic system versus when they are set to 100%. We can see from the simulation when the one-way flow control valve is set to 100%, the piston rod will move forward and back fast because the air pressure supply is 100%. When the one-way flow control valve is set to 10%, the piston rod will move forward and back more slow than the 100% setting because the air pressure supply is only 10%. Question 1. Discuss the function of this component below at B1 and at B2, which is not that the direction of both is opposite to each other. A check valve is a device that only allows the flow of fluid in one direction. They have two parts, one edge and inlet for the media and one as the output for the media. Since they only allow media flow in one direction, they are commonly referred to as one-way valves or non-return valve. The main purpose of a check valve is to prevent backflow in the system. A check valve relies on a pressure differential to work. They require a high pressure on the input of the valve than the output side to open the valve.
So for lab activity, we must click the play button first. At the rest position, the air from air supply flowing to 4 different parts. For the first part is to A1, which is mechanically operated valve, A2, A3, which are same as A1, which is mechanically operated valve. The air from air supply will also flow to C, which is pneumatically operated valve. The air will flow through this part and entering the back part of the piston, making the piston to compress. When I press the pneumatically operated valve C, it will move to the right and making the air flow to the front of the piston and making piston to extend. But when I press A1, it will move to the right and making the air flow to the front part of B, which is two pressure valve, and here the valve at the middle of B will move to the right, making the valve blocked. So the air cannot flow upwards to C. Same goes to A2. When I press it, it will move to the right and making the air flow to the left side of B and making the valve at the middle will move to the right. For this case, also the valve is closed and the air does not flow to C, which is pneumatically operated valve. But when I press A3, the air will flow to C and make the valve to move to the left. The air from the air supply will flow to the back part of the piston and making the piston to compress again. So A1, A2 and A3 are mechanically operated valve, where if I click it once, it will only tickle one time. But for C, which is pneumatically operated valve, if I press it once, it will only move to one position, and it make it move to actual position, we have to click it again. This is because C has no spring at the back side, while we can see the spring in A1, A2 and A3, which make the valve return to its original position once we click. Okay, so let's move to the observation part. So observation number 1, describe how to activate the actuator below. As we can see, this actuator is actually at C. There is pneumatic operated valve. When we turn on the switch, it is actually activated. So to move the valve here, there are two ways. First, press the valve to change its position, which is it will move to the right. Second, press the A3 will also make the valve to move to the left. Question number 1. Show the component used for logic function in the circuit. These are the components used, which is piston, pneumatically operated valve, two pressure valve, A1, A2, and A3 are mechanically operated valve, and also this one, which is compressed air supply. Second question, state the logic function implemented. In this case, it is an OR function, because to move the piston, we can either press the valve C, or we can press the valve A3. Number 3. Explain why C does not need a spring. As we can see, C is pneumatically operated valve. This means it will operate due to air supply and air pressure at different ports, which is from left or right. So this valve does not need a spring operated like A1, A2, and A3. This valve will operate based on the different pressures at the left part and also the right part of the valve. So that's all from us. Thank you.